Algebra 2, Lesson 46, more on radical expressions and radicals to fractional exponents. We'll be starting with practice A, and looks like practice C, so we'll be doing A, C, and then we'll also be doing example 46.5. So starting with practice A. Before we start, we have to rationalize these fractional exponents, so we'll go ahead and do that now. Multiply this one by root 3 over root 3. This one gets multiplied by root 7 over root 7. So that turns this into 3 times the square root of 21 over whole number 3. That can actually cancel, so that just becomes 1 times the square root of 21. And then we're going to add 5 times the square root of 21 over 7. And then we're going to have to subtract the square root of 84. This can factor. See, that equals root 7 times root 12. 12 will factor into 4 and 3. 4 factors into 2 and 2. We've got a pair. So then we get whole number 2. And then the 3 and the 7 have to multiply, so times the square root of 21. So we'll rewrite root 84 as minus 2 times the square root of 21. From here we've got 2 whole numbers and then 1 fraction, so we'll have to multiply everything. We'll have to multiply these two by 7 over 7 to give them the common denominator of 7. So once we do that, we get 7 root 21 over 7 plus 5 root 21 over 7 minus 14 root 21 over 7. 7 plus 5 add up to having a mind blank. 13. So that gives us 13. 13 minus, I'm sorry, not 13, 12. Ooh, having a rough morning. Alright, 12. 12 minus 14 gives us negative 2 root 21 over 7. And that is let me double check. Yep. Okay, yeah, that's our final answer. Alright. Having a tough addition day. Alright, now moving on to fractional exponents, or turning radicals into fractional exponents. So what we're going to do here is we're going to turn both these into fractions, but we have to work our way from the inside out. So this first one we'll write as root 7 times 7 to the 1/2, and then we'll go ahead and take the 1/2 of these, or another way we could do this is we could just write it like this. Alright, so from here we just use distributive property, and then we get 7 to the 1/2 and 7 to the 1/4. When we combine these, we get a final answer of 7 to the 3/4. And that is our final answer. So fractional exponents are pretty easy if you've been doing good with fractions so far. Now let's go to example 46.5. Same thing, but this one's a little bit more difficult because we've got a cubed root and we've got multiple radicals being multiplied. So we'll go ahead and take these, and we'll use this parenthesis method that I did up here because that seems to work best. We don't have to work inside to out, so we'll just go ahead and put all of these inside parentheses and multiply them by the exponent of 1/2 to replace the radical. And then this x and y will get multiplied by 1/3 to replace the root, the cubed root. From here we just use distributive property. That becomes x to the 3/2, and then y to the 1. And this becomes x to the 1/3, y to the 1/3. From here we just add like terms. The x's, let's see here. Let's go ahead and do 3/2 plus 1/3. That becomes 9 over 6. This becomes 2 over 6. 2 and 9, 11 over 6. So we get x to the 11 over 6, and then that becomes y to the 4/3. And that is our final answer.